Good evening. Welcome to Whiskey Talks. Whiskey Talks is a monthly webinar series at our regional innovation hub in Peoria Distillery Labs. And tonight we have Steve Pierz, Chief Innovation Officer of FBR, that's headquartered in Perth, Western Australia. Welcome, Steve.
Thank you.
So, Steve, if you can share briefly about FBR and how you got to this opportunity as the Chief Innovation Officer here remotely in Peoria.
Sure. Um, FBR is a robotics technology company that is looking to disrupt the construction industry. So we are a robotics technology company first. And the problem with um, the disrupting of the construction industry is the fact that we can't take robots out onto the job site because of the elemental variations, wind, rain, and so on. FBR has developed some very unique technology that enables the fine placement in actually 6 degrees of freedom. So we have very tight accuracy on where we place objects in three-dimensional space. So how I got to from Peoria, Illinois to be the Chief Innovation Officer at FBR, kind of a long drawn out story, but really boils down to innovation at Caterpillar. I was on a team that we looked at the disruption of the construction industry and more vertical construction as opposed to horizontal. Because if you're going to disrupt something, chances are, if you're in the industry, there's too many paradigms associated with it. A good example is Uber wasn't a cab company, Airbnb wasn't a hotel chain. So we were looking at adjacent space disruption. And essentially, when you look at the $10 trillion pie for construction industry around the world, only 3 or 4% is actually horizontal construction, where Caterpillar plays. 96 to 97% is vertical. And so we were looking at opportunities for Caterpillar to have an adjacent space innovation disruption. And so we looked at digital construction, the idea of leveraging the BIM file to go straight from a BIM file to a finished structure. And so we were looking at 3D printing, the analogous in manufacturing between a CAD file and a drawing. So if you have a CAD file, you could take that file and download it into a computer, CNC, and it will actually produce a part. On today's construction site, they have a CAD file called a BIM file that is manually interpreted. Robots don't take that information, so there's not computer-aided construction yet. And FBR, so at Caterpillar, we were really looking at that. And one of the first real pushes was into the 3D printing of concrete. And, because the people on the team, the Jay Babbins, the Chris Sketches, and Tajio Gravetti and various other people on the team, we had a lot of experience in 3D printing. So it was a natural extension to look at 3D printing of concrete. And so when we did that, we found that there was a lot of limitations associated with 3D printing of concrete. The fact that you're using a slurry that you're pumping through. Pumping a slurry is very difficult, especially with aggregate that you don't have separation. Then when you put too much on top of each other, it slumps, it crushes the first couple layers, which is a problem. Then it dries at different rates, and there's a lot of problems associated with it. And in about 2015 timeframe, I think it was, we were working with Baroque from Contour Crafting, really pushing the 3D printing of concrete pretty hard. And we saw this video on the internet of this company that was leveraging a 325 excavator, and with a brick on the exterior, it went up and over and it placed the block and actually built a structure. And we looked at each other and said, holy socks, this is, it solves the problem of wet concrete. And you can actually, because it's dry, you can build a lot faster with it. And so we were looking at it and saying, okay. And the experts at CAT said, well, if you put a 3D printing head at the end of an excavator and move it around, you're going to overshoot by a couple millimeters and then correct, and you're going to get this wobbly. So every corner will look, pretty sloppy. So we looked at this and said, wow, that's pretty disruptive. And at the time, I thought it was really cool. And so I told my wife, Leslie Paulson, who was heading up OEM solutions at Caterpillar that sold partial machines to non-competing companies and components, hey, you need to check out this company in Australia, because what they're doing will change the world, and you'll sell a whole bunch of excavator bodies for it. And so she got in touch with them. The timing wasn't right, and they said, hey, no, we're not going to put it on an excavator base. We're going to put it on a truck base so we could drive it around much more efficiently. We don't need a low boy to move it around. So it was okay, that's fine. And by happenstance, they happened to meet with Bechtel, the construction company. And we, when I was at CAT, we had a lot of discussions with Bechtel about innovation in the construction space. And they said, well, you need to talk to the innovation group at Caterpillar. So they had no reason to come to Caterpillar other than Bechtel said that you should go visit Caterpillar. And they said, well, we're going to be visiting Deere FBR at the time, Fast Brick Robotics. We're going to be visiting Deere. It's just 80, 90 miles to Peoria, so we'll stop in there. And we started talking with them. And, they claimed they could hold a millimeter tolerance. And it's like, no, our experts said it's, centimeter or two. And then I started talking with Mark Pivak, the CTO, the one who developed the technology. And I said, what is your background? And he said, aerospace engineering. And I said, you know what? We might have something disruptive. So rather than looking at it from a total station, the way we do in construction, they looked at it as a laser and a guidance as opposed. So it was a perpendicular approach to solve the same problem. So this was pretty disruptive. And then it was like, okay, well, what are you doing with mortar? You could stack blocks really well, but these aren't the pyramids, we use mortar here. And he said, well, the way we do it is we actually use adhesive. And he said, although it sounds strange, it's used in Europe all the time, using adhesive between blocks, as well as construction adhesive. Oh God, what's this stuff in the tube called?
The caulk?
Yeah.
Silicone caulking? Yeah.
Yeah, but there's an actual construction adhesive that you use for wood and so on. So when we looked into it, the adhesive, a polyurethane base, was actually stronger than the block. So rather than it cracking down the mortar joint, it actually is stronger than the block itself. So now the wall is 3 to 5 times stronger. So you have a means to go straight from a computer program, accurately place a block plus or minus a millimeter in 3 degrees of freedom, X, Y, and Z, as well as the 6 degrees of freedom if you want any angle or pitch or yaw on it. And so you're able to lay the block, you put adhesive on it, and then it's actually stronger than a conventionally built wall. And it's like, holy socks, this is really disruptive. Around 2016, left Caterpillar, and then started my own consulting company. Started my own consulting company
So
called.
Steve, I have to pause you there for a second because one of the things that our viewers don't know is that you went to Singularity University. So, to help people understand, this amazing journey that you have that has led you to FBR now. At what point were you exposed to exponential technologies and the entire framework that is being taught at Singularity?
Well, I'm glad you brought that up because, quite frankly, that was the genesis of really my passion. Because when I went to Abundance 360 with Peter Diamandis, and then a couple months later to Singularity University, I learned about exponential technologies. I always had this gnawing feeling in my gut. Ever since I saw the internet back in 91, 92, during summer work at CAT when CAT was shut down, they took us younger people who didn't have vacation time, and we played around on the internet, and it was really cool, leading edge stuff. And I've always had this gnawing part of me that's saying something's different. I never felt comfortable. There was so much change going on, and you see it all around you, but I just couldn't put my finger on it until I went to Singularity University in Abundance, and Peter Diamandis talked about we're truly living in an global and exponential world, not a local and linear. 99.9%, and I'll even put me in there because I still think locally and linearly, it's truly global and exponential. That our minds understand what 30 linear steps are, about 100 feet. We understand and, that, friendships are face to face. And what Peter talked about was the 6 Ds of an exponential technology. Once you digitize something, there is absolutely no cost to replicate it, to send it, and so on. Unlike a conventional piece of paper, a print, or whatever that you have to put in the mail, address it, and send it, and weeks later it ends up there. So once you digitize it, it grows disruptively. It doubles every couple of years following Moore's law or close to Moore's law, depending on which technology. Then it hits a point where it's that knee of the curve, the disruptive point, that it starts to be better than the current technology. So when you think of photography, it was actually developed in 1976 by Steve Sasson, but it was 0.01 megapixels. By about 1998, when the first digital cameras came out, it was approximately 10 to 12 doublings, or about a million times better than it was, back, or, when it was first invented. So now it was slightly better than the old 110 Instamatics. So people who didn't want to go to the store and buy film and all that, but once it becomes disruptive, it dematerializes. So now, instead of having my wallet full of pictures of the family, I just take out my phone and show pictures of my family. I have a lot more, they're more up to date and so on. You can share them. So it dematerialized the photograph. Once it dematerializes, it demonetizes. So now you cannot charge $1 for a picture on your phone. You know, it's a matter of millicents. It's so cheap that, you know, you just take as many pictures as you want. Once it materializes, demonetizes, it then democratizes. Everyone can use it. I grew up in a family of 7 and I'm number 5. So if you look at all my parents' photographs, there's a bunch of just my oldest brother and then a bunch of my oldest sister. But anything after the first 2, whenever they took a picture, everyone was involved. So now, once it democratizes, even if you're, you know, the poorest of the poor, you've got a film, or a phone. You take a picture and you load it up to Facebook. Everyone has their own identity that they can post. So fast forward, I learned about all this, and it's like this aha moment hits me. It's like, that's why I was feeling so uncomfortable, is I knew I wasn't living in a linear world. It was truly an exponential world. So 30 exponential steps instead of 1, 2, 3, 4, 5, it's 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. So very quickly, you start to leave the linear path. And it was the distance between the linear thinking and the exponential reality that was the gnawing in my stomach. And every year it just kept getting worse and worse until now I understand why it was happening, which then allows me to, you know, look at companies like Tesla and buy in when they were 17. Look at companies like Roku and buy in at 23. They're up over 400 now. You understand which companies are exponential and which ones are based on local and linear thinking. So
Can I pause you there again?
sure.
Because you are just so full of insight and information. Now, you know, we talked about the Abundance 360, we talked about singularity and the exposure to exponential technologies. But, you know, even before then, I want to kind of rewind a little bit more. Were you like this when you were growing up? What was that like?
Sure. Growing up, my dad was an engineer. He had an amazing ability. He was doing die casting, inventing die casting machines, and this is in the early 70s and so on, late 60s, early 70s, and doing many things, advancing the aluminum zinc die casting, was, you know, giving talks around the world, recognized as a world leader in die casting. And his philosophy was that you can learn something from any industry or anybody. And so we would be driving, you know, in our 9-passenger station wagon, you know, the old the minivan of the day, you know, where you pack all your kids in there. And he would just drive and see a factory and stop. And he would grab us kids and walk in and say, "Can we have a tour?" So I was always exposed to new things. And then the other thing is my dad set up die casting factories in Ireland and Canada. So I was exposed to different cultures as well. And one of the things about innovation is there's 5 skills: questioning, observing, networking, experimenting, and associating. My dad was amazing at all of them. You know, the associative thinking. What are they doing in this industry that I can pull into this so I don't have to invent? But what they say about innovators is when you live in different countries or visit different countries, you become very aware and your observing skills become very acute because you don't want to look like an idiot. You don't want to hurt somebody's feelings. So you become very sensitive to cultures. And the design thinking is based on empathy and observing and being empathetic for your customer. So a combination of an amazing father and mother. My mother was a school teacher. You know, one of her favorite rainy day activities was to get pistachio pudding, chocolate pudding, and vanilla pudding, putting a big tarp over the kitchen table and pieces of paper, and we would finger paint with the different colored puddings. So you lick your fingers and it tastes great. You know, so you have all this stuff, it dries. So I had a very creative family and one that loved learning, constant learning, you know, so just constantly expanding your horizons and thinking. So truly blessed by really great parents who really allowed me to be me and to be creative and to make mistakes and not really care one way or the other. Just, well, if it didn't work, try again. Yeah.
So you make a really good point. Your dad was in engineering, and then your mom was in not only in education but also fostered the exposure to creativity, and more importantly, curiosity. Well, what happens if you do this and you do that, and the resulting result is, hey, experimentation. The other thing that you kind of talked about too is the idea of, and of course, at the end of the day, innovation is messy, and innovation, typically happens at the edges of any organization or any team. The other point that I wanted to also point out, and we both took this course, the Innovator's DNA, of course, right, by Clay Christensen from Harvard Business School and others in CIET, etc. It's about the innovation horizons, right? The exposure that you had from such a young age that then exponentially, shall I say, grew
Mm-hmm.
into what you've become now. Can you share more about the innovation horizons as you developed, in your growth into where you are now?
Sure. There, there's kind of two different levels. And the great thing was I was always an innovator. And but the idea of the serial innovator, I never read anything about it, never read anything about innovation. It was just who I was and how I did things. And a real funny story how at Caterpillar, I just did a urethane tire project where we looked at disrupting the off OTR tire using a non-pneumatic tire, and had some really interesting success with it. And it really got Caterpillar excited about intentional innovation as opposed to accidental innovation. So we went out and benchmarked Exxon, their innovation program and so on. And we were talking about what we were doing, and then they gave us kind of an overview of innovation. And they talked about something called the uh, innovators. The word just popped out of my head. The constant serial innovator. And so they started listing all the characteristics. And Greg Foley was there, and several other people, including my boss, Judy Swanson. And throughout Caterpillar, I was always kind of seen as the odd duck. I would do my job and, do it well. But by the time I was done, the process never looked like what it started out to be. I always had to do something, had to improve it, and then I would find a curiosity that led to passion. And then I would get people to, buy into the vision, and we would do it skunkworks, no funding, nothing. I I actually did some apps on OS2, the IBM software touchscreen, before apps were even invented, where we took a bulldozer and you touched the undercarriage, and the undercarriage would break out into the various components. You touch the component like a link, and then you touch the point on the link where the failure was, and it would show you the 10 most common failures. And if it wasn't there, it was kind of an expert system to walk you through what tests you would need to verify what type of failure mode. So I was doing apps back in the early 90s, didn't know. But once again, it was the curiosity that drives passion. And so anyway, at this Exxon meeting, they were reading off the 10 characteristics of the serial innovator. And, I'm kind of like that, the black sheep where, yeah, he does, and so on. And pretty soon, every caterpillar head started turning towards me. And he said, that's what you are. You're a serial innovator. And the interesting thing, serial innovators are about 1 in 50 in the normal population. In a corporation, it's closer to 1 in 200 because a couple things happen. When somebody like myself brings up an idea, the experts would come in, the technical stewards will say, that's the dumbest, it won't work because of this, that, and the other thing. They'll tell you 100 reasons why it won't work. And if that doesn't distract you enough, then they will start attacking you personally. And so what happens is the serial innovators, one of two things happen. Either they put their head down, never come back up, and just do their job, or they quit or get fired. 3 things. If they stick to their guns, they get fired. If they put their head down, they will go home and find another creative outlet for their energy and their passion. Or, like me, you just beat your head against the wall and think that that's normal. But so, prior to that, it was all me and my innovation, looking at ways I personally can innovate, come up with patents and ideas. After I went to Singularity, I realized, and the Exxon trip, I realized I wasn't the only one. And so I turned it from inside to how can I find and create a safe place for the crazies. And I ended up creating the Center for Innovation in Disruptive Technologies, created the Friday Coffee Talks in Disruptive Technologies to allow people who were like me a safe place to express their ideas, and you get the Jay Babins, the Tazios, all the innovative people at Caterpillar. We had this real cool group that we were, on fire. We had this, high performing team that we didn't look at any problem as a problem. We took it as energy, as fuel to, really change things. So it was an amazing time. But like I said, I went from being where the innovation was mine to finding those 100 people who have been beaten down and try to help them be their best people, realize their potential, and elevate them. Because if there's 100 of them and only one of me, the 100 have a lot more ideas and a lot better ideas than mine. So supporting them became my mission after I went to Singularity. I've been there Abundance 360, 8 of the 9 years that they've had it.
That's really amazing because I just had a presentation just yesterday where one of the presenters actually said, "Hey, there was a quote from a Jewish rabbi. If there are two candles, and mine's lit, and if you get the light from my candle, are you taking from me? Actually, no, but the room gets brighter." And so that was like, wow, light bulb moment right there. And so the work that you've been doing at Caterpillar in not only setting up the innovation center, really paved the way forward for these incredible, I guess, radical and disruptive innovations that Caterpillar is the company and corporate global organization it is today. I want to kind of go back to the pneumatic tire, right? Can you share more about what you saw? And before I go there, I want to talk again, you talk about exponential scale. So you were one person as a result of your pushing the envelope. Now Caterpillar has the coffee talks, they have the innovation center that has exponentially grown, and the market cap for those kind of innovations is pretty exponential when you started with zero funding. But yeah, I want to go forward to the non-pneumatic tire. How did you figure out that the problem versus the symptoms that you were seeing on the remote locations?
Sure. So back in 2005, 2006, the world was blowing and going. You could not find a pneumatic tire to put on machines. And most people think of Caterpillar as a track company, but more than 50% of all machines that Caterpillar sells are actually on tires. We don't make any tires. It's Bridgestone, Michelin, Goodyear, and so on that supplies tires. And it's not, a few $1,000s. Caterpillar buys over $500 million worth of tires every year, tires and rims. So it's huge. And I was the tire manager, product manager. And in the 2008, 2009 timeframe. So we just hit the recession, where things were blowing and going. You couldn't get any tires. And Caterpillar at the time, prior to me, all the tire buying was done by the individual facilities. So Michelin would get the Aurora facility to bid against the Decatur facility for the tires. So, internally, we were raising the price on ourselves. It was total nuts. And then around the 2000, I think 6 or 7, a great gentleman, hopefully, somebody out there might know him, Dan Gove, was put in charge to rein in all these spreadsheets and, get all this under control. And so he moved on, and then I moved into the position, did several strategies for the tire group at the time. So pretty in-depth knowledge of it. And the big tires are only made in a few locations around the world and shipped. And it's like, this is really bad, because when I took over, we literally had hundreds of millions of dollars worth of tires in inventory that we couldn't get rid of because no machine was selling in 2010 and 11 timeframe. And so I had to sell on the open market these tires for pennies on the dollar. And I was being congratulated for getting rid of them. to get the inventory off the books. So then mining industry took off like a V in the 2012-13 time, 11-12 timeframe, just took off. And there became a massive shortage of these huge tires again. And these huge tires for our large trucks and wheel loaders would sell for anywhere for the second largest size, 130 to 180,000, and then for our big trucks, the 797, as much as $300,000 per tire. So you need 6 of them. That's $1.8 million, and a set of tires wouldn't even last you a year. Huge bucks. So sales of machines were dependent on getting tires, and if a customer couldn't get tires, then they wouldn't sell the trucks. So I was asked to talk to the Tire Industry Association, the TIA, out, I think it was Portland or somewhere, the huge annual gathering. And I was either the keynote speaker or something. And I went up there and I said, you know, I'm Caterpillar. We buy a lot of tires. You don't think about it, but we buy a lot of tires. I want tires when I want tires. I don't want tires when I don't want tires. I want to tell you, I'm building these machines tomorrow, and I want you literally to roll them from across the street into our factory. I want it just in time. In the current model where you produce in one location and ship around the world, everyone just laughed at me. This tiny chemical company called Chemtura. I'm sitting there, people are talking with me, and they're just sitting there waiting patiently. You know, I didn't know, I saw a couple people standing off to the side. Finally, people left and they came up and talked to me, and they said, hey, we think we have a solution using a special type of urethane. Okay, this is radically different, non-pneumatic and so on. So listen to their idea, listen to their concept, saw some videos of some full-size 13-foot diameter tires they had in tests up in, you know, the Alaska Gold country and so on, and seemed to be working. So it's like, okay. So got some prototype parts in, tested them, you know, had some operators from 6 different mines come and test them. And it was kind of funny. They wanted to rip, because urethane was actually molded to the rim. They wanted to rip it right off. So they'd go with 320 ton in the back, going 40 miles an hour. They emergency stopped it, you know, trying to rip the tread right off the rim. And nothing. And then they went over a few bumps and fully loaded, and it's like, well, that's not too bad. And then they started turning it, and one of the operators said, because they were low sidewall stiff tires, they said, this handles better than my BMW. So it's like, okay, we have something here. So then finally got Caterpillar to agree to fund the innovation of developing a non-pneumatic tire. I said, you know what, I can do it in a year. And this is like the September, October timeframe, just before budget. And so, you know, I said, I need $10 million. I'll design a factory and design a tire, and with 1 year. They said, you're crazy. You are absolutely crazy, because it took Michelin 5 years and hundreds of millions of dollars to develop the first tire for the 994, the wheel loader. And let alone the factory to produce those tires is in the hundreds of million to $1 billion greenfield. And they said, you're going to do it for $10 million, design a tire, produce a factory, and get it out in the field in less than a year. And I said, yeah. So needless to say, my performance evaluation, I had some input from other people said, um, although he has a lot of good ideas, he's absolutely nuts. He doesn't know what he's talking about. Engineers, the same comments, it's like, no, once again, water off a duck's back. I was the odd duck, so it really didn't. But we actually got the group president, Stu Levnick, to agree to it because we had some of these test tires out in Pennsylvania. The mine owner, Dave, and I forgot Dave's last name. Unfortunately, he died in a mountain biking accident. Great guy. But he took Stu and had Stu drive the truck right in the mine. And Stu saw that they worked. The mine owner said, these work, and if you could get me these, I'll put them on all day. So then Stu said, okay, you think you could do it for 10 million bucks? There you go. Well, I thought I was going to start January. By the time I got the money, it was end of February, early March. So I couldn't start clearing out the factory in Mossville, which was a warehouse that we were going to convert. But we started designing the facility, and we actually used a 10-inch diameter model of the tire. Some great people, Kevin Martin, and I forgot the other people at the tech center, did all the FEA. And the cool thing about the urethane, it was one system. So you didn't have to, like a pneumatic tire that's layer upon layer, that's a very complex model, and you couldn't do it. So they designed the tire, did all the FEA. We took it, put it on a dyno, simulated the loads, worked out great. And then, we designed the factory and started doing it. And before October, we had the facility in place, and we actually poured the tire. And then I went out to the mine over Thanksgiving and actually saw the tire in action on the mine site. But the interesting thing, the individual who said about you'll never create the factory in a year, because nobody's ever poured that much urethane. I said, it's like making a pan of brownies. You have A component, you have B component, you mix it up, you pour it in a mold, you throw it in the oven, you bake for 24 hours, you pull it out. That one project, within a year, I think we have over 25 patents on the entire project, because we're just making this stuff up all along. And I could go into some stories about managers needing a waterfall versus agile, that they don't understand it and the problems that's created. But the fact is, we were making this up. We were agile before I understood or knew what agile was. We were this high-performing team before I knew what a high-performing team. And none of us, I wasn't, I was a team lead. Nobody reported to me, and we all just performed amazingly and accomplished something that everyone said, you are nuts. There is no way you could possibly get it done.
Yeah, so Steve, you make a really good point, right? Of course, unless you've been through the course or you've read a book about the innovator's dilemma, there's this dichotomy between traditional management versus innovation management, where there's significantly high levels of uncertainty. And so, what the corporations typically tend to do is that any corporation or any sort of body, and the best way to look at it is from the functional body that we live in. We all have an immune response, and similarly, in a corporation, as a living organism, there's a immune response, and as a result of that, they are used to traditional management, which is top down, because they've found product market fit, they've found systems and processes to make those things happen. And so as a result of that, This is where the high level of certainty is. But of course, when you're looking at innovation, then there's such a high level of risk, there's such a high level of uncertainty, and there's, new ways that are required to manage in innovation, right? Obviously, stage gating and waterfall is great, but we kind of pushed it on to later stage of the organizational curve. Now, I want to thank you for sharing that, Steve. I want to come back to FBR.
Can I make one note
Yes,
before?
go
I
ahead.
love that, and it's the associated thinking that you did between that and the immune response. I'm the serial innovator who doesn't get beaten down is a fast mutating virus that you can, get mad at us, kick us out of one place, throw us in another. We'll just mutate and do the same thing over here. So I love your analogy, especially with what's happening with COVID. The serial innovator is a definitely mutating organism that will put up with whatever and do what they love to do.
And I want to draw one more parallel. It's like the mycelium, right? The
Mhm.
corpus or the body, it remains underground until such time that it fruits, and it only not only fruits in one place. You cut it off, it's going to fruit in somewhere else.
Exactly. Another great analogy.
Okay,
Oh,
so now
all
let's get back to FBR because we're
right.
we're going to be about out of time very soon. I understand you have a picture of your the work of innovation that has with FBR. Would you be able to share the picture of this? The I think it's the vehicle, the Hadrian.
Yeah, I'm going to put an actual video behind me so we can talk about it as it's playing the video, because
Perfect.
it's the way I would describe the Hadrian is real life Minecraft. So I'll kind of get off to the side. And this is actually in a neighborhood in Australia that the machine, the Hadrian, is pulling up, and it goes straight from a computer program to a finished structure. You load the blocks in the back, and that's the only time they're touched. So it's lean construction, and it's placing those blocks at plus or minus a millimeter in 3 degrees of space. Can work day or night, rain or shine, and it uses the adhesive. It sets up in 15 minutes in normal. If it's raining, it sets up in 5 minutes. So notice there's no mortar, there's no sand. It's a clean job site. It's a lean job site. Touch the block once, and we're actually building at a rate of about 280 to 300 blocks per hour. Put it in perspective, the typical human can only lay 150 to 180 in a day. So this can work 24/7. You just keep loading blocks in the back, and the computer program knows exactly where they're going to go. The other cool thing about a program is you can simulate it before, understand exactly where the pinch points are, exactly where, and modify the design before you even go. We know exactly how many blocks, how much waste. We get waste to under 0.5%. Typical waste in block is anywhere from 7 to 10%. We're 10 times faster, 10 times more accurate. Safety is, off the chart, and so on.
I mean, this leads to so many questions, Steve,
Okay.
and things like how do you deal with plumbing or electrical, and you mentioned that you can actually build in the rain. Typically, masons don't build in the rain, correct?
No, they don't. And, just like the um, 3D printer, I could 3D print this cup, but if you can see it, yeah. a horrible waste of a 3D printer. You want a 3D printer to do generative design and do things humans can't. So if you take the mindset, we're going to do plumbing and electric the same way as we did before, you're sub-optimizing. And so today we have the plumbing coming up from the bottom. Well, there's no reason why you can't build a chase on the outside and have the plumbing come in from the top. So then you have a clean slab and things come in from the top rather than from the bottom, where you have all your freezing and so on.
So, this is pretty incredible. And so, you met FBR through your work at Caterpillar. And so, how did you end up joining FBR and I would say working remotely from Peoria,
Sure.
Illinois?
So when I had my own consulting company, Exponential Insights, in case anyone, it's still going. But FBR, we talked subsequently, and I developed a really good friendship with Mike and Mark Pivick, the CEO and CTO. Obviously, as I talked with them about the potential that, it's more than block laying. You can pump concrete through it. You can put roofing on with it. You can, what we have here is the Wintel for construction robotics. It's the hardware and the software. What program you put into it, whether it's Excel, PowerPoint, or whatever, it can run it. So I started to talk with them about all the potential that could be putting a different work tool on it. You can put the first concrete pumper on it and pump and do the slab at plus or minus a millimeter. Then you can take that concrete pumper head and put on the block laying. Then you could put another head and insert all the windows and doors and on and on. So it becomes one of a multi-tool machine, because what the dynamic stabilization technology, the wind is blowing there and it can gust up to 25 miles an hour and it's correcting the position 1,000 times a second. So it looks like it's standing still, but it's making all these micro movements. It's decoupling all the movement from the stick and boom such that the head is perfectly still. It's like taking that chicken and shaking the living crud out of it, and its head stays perfectly still. So this application is a block layer. You could put concrete pumper, you could put roofing material. And then the other potential is that the block there is the size it is because a human has to be able to do it day in and day out and so on. It can't be too heavy. Well, now you have a robot on it, you can make it really small, like a voxel. If you think of 3D printing concept, where you have multiple little blocks, or you can make them huge and have the robot place larger blocks. You're unconstrained by today's building methodologies. And my feelings are, is it going to be a manufacturing company? Is it going to be a stay-at-home mom or stay-at-home dad that disrupts the residential building because they can approach it from perpendicular? We don't have to do it the way. Maybe it's some kid who played Minecraft who said, holy socks, I've got, a mechanical Minecraft right there, and I can build curved walls. A computer, it's hard for a human to build a straight or build a curved wall. It's easy to build a straight wall. That's why all the walls are straight. You put a slight curve on them, the wind will go right around it. A great example is you hold a sheet of paper up and you blow on it. When it's flat, it'll blow right over. You put a slight curve on it and you cannot blow it over. So places in hurricane, you could put a slight curvature that would be very difficult for a human, but the robot doesn't know. It's just like 3D printing.
Yeah, you make a really good point, and I think you also really make a good point with, you know, and we always hear this argument with fear-based argument, okay, and it's always about perception, right? The robots are going to steal our jobs, right? But at the heart of it is allowing technology to do what technology does best, and for humans to actually focus on the things that humans do better than computers and technology.
I can't say it any better than you just say it, but the way I say it is, you know what? That wall, a square meter of wall that you're going to cover up, like the wall that was behind me, that you're going to cover up with paint. A skilled mason doesn't need to do that. You know, you're going to cover that wall up. So, what we need the humans to do, you know, like we talked about at my house, I live in a 120-year-old, beautiful red sandstone, red brick house. Let the masons that are left do that creative, high value add. Let the robots do the dull, dirty, and dangerous that have very low add. It's kind of like the rebar of the steel industry. The block is the rebar of steel industry. A lot of it, but it has very low value. But you need that structure, and instead of that structure being done in weeks or months. Now you get it to days. And like I said, typical house is about interior and exterior walls, maybe 2 to 3,000 blocks. So that's roughly a day to 2 days, depending on if you could build what your build time is. Certain regions have, you can only, construct for 8, 10 hours or during daylight or whatever. But and the we have designs that could potentially do up to 1,000 blocks an hour. So now you're building houses in an hour. And curiosity leads to passion, leads to purpose. The curiosity I had with digital construction led to my passion of the how do we solve when we were looking at digital construction. There's between a billion and 1.5 billion people, and it's getting worse. People who have inadequate or no housing around the world, the favelas in Brazil, and you see the deplorable housing conditions. How can you realize your human potential when you don't even have Maslow's basic needs covered of safety and security with shelter? So the way we're doing it today hasn't worked, and fewer young people want to get into it. So my curiosity turned to passion. My passion has turned to purpose. And the great thing about Mark and Mike, the CEO and CTO, to get back after I did, here's all the potentials for your tool. They said, how would you like to work for us? And I said, I never thought you'd ask. This is a dream come true. And then they gave me a real cool title and, allowed me to stay, even though right now Australia would be a lot better place to be, just saying. But the fact is that this type of technology, and I'll throw 3D printing in there too, the work that Icon's doing and a lot of other great digital construction. It's kind of like the electrification of the automobile industry. This is the digitization of the construction industry. A lot of stuff is being done prefab in factories. We're going to do it out on site. So,
just re-watching this video in the background going, and it's just hitting me right now. Two things, and we'll hopefully close off very, very quickly after this. But two things. First thing is, what is the future of the Masons 2.0? That's the first question. And then the next question, with exponential technologies, typically we're looking at opportunities to bring it mainstream, and that really looks at commercial application. I'm curious why FBR is still looking at residential applications.
Okay, so great questions and comments. You know, the first thing is, you know, the exponential nature of this technology. It's only going to get faster, better, and cheaper. Humans are only going to get slower, and there's fewer people, young people, that want to become masons. Let them do the high value add, you know, the brickwork behind you. Let them do that type of exposed stuff. Let the robots do this. It's an and, not an or. It's not humans or robots. It's humans and robots, very much like the factory. So as I talked about the 6Ds, digitization, disruptive growth, disruption, then dematerialization, demonetization, democratization. So right now, this actually started in 2005 with two robotic arms trying to butter a brick and, you know, put it. It has been through this digital journey of getting a little bit and little bit better. The technology, the computational is such that you can do what we're doing today or last couple of years. So we're only going to get faster, cheaper, better. The thing I want to point out is the dematerialization. Notice there's no scaffolding, there's no shovels, there's none. It's a clean job site. If you go out to any block laying that's, you know, above 3 feet, you're going to see scaffolding. You're going to see people touching blocks 6, 8 times before it gets put in place. So it's lean construction. So it dematerializes. It's going to demonetize because, yes, this machine today is very expensive, but the cost trajectory is down. If we go from 300 blocks per hour up to 1,000 blocks per hour, you know, it's 3 times faster. So now we can do it much faster, much cheaper, and so on. Once you now you dematerialize, demonetize, now we can democratize. Now we get the cost of that machine down to the point that we can start bringing it to Brazil. And, you know, where in Mexico, it's about 50 cents per block laid. In the United States, it's $15 a block laid. It's a Tesla Roadster, you know, getting down to the S, the X, the Model 3, the Model Y, and then maybe the Model 2. It's going to take a couple iterations, but if every couple years we can drive the cost 50% lower, it's not many before we are actually cheaper than the lowest cost block laying place in the world. And we're now, we built our first residential that you see. We built our first low-rise commercial building. And then we built our first 2-story building. But it's a whole different mindset. You have a new tool here. You make it up as you go. It's like, can you do this? It's like, I don't know. Let's try it. You know, until you break something, you don't know. And so Mason 2.0, construction's going to get interesting again. I was going to say sexy, but, you know, young people will be attracted because now when you say, I actually operate one of the world's largest robots, you know, it's not, I hump block, you know, I'm a laborer. No, I am a robotic operator and I build houses 10 times faster than my dad, who might have been a mason, and so on. So I think construction, $10 trillion and growing industry, will start to be digitized. It will start to go through this technology shift, much the way manufacturing did. You know, when I had one of the first 10 seats of pro engineer at Caterpillar, back when PTC was just a startup themselves, I didn't understand the pebble that created a tsunami of change in the manufacturing, digitizing a physical part, which led to computer-aided construction, computer-aided manufacturing, CAM, disrupted the whole Bridgeport, the single-use tool, and it has a ripple effect. This, right now, you're seeing the future. This is the future. It's just not equally distributed. This will change the way construction is done.
That is so awesome. Thank you, Steve. And just so our audience can understand, where is the FBR Hadrian Axe operating right now? Is just in Perth, Australia, Western Australia, or where is that?
So COVID, it kind of a double-edged sword. It prevented us from leaving Australia this year. We were going to demonstrate building of the home. We were going to, take the Hadrian to different parts of the world. If it was up to me, it would come to the US. It is somewhat up to me, but not fully. So hopefully it comes to the US soon. But COVID really shut it down. So we built several structures in Western Australia. It's easier to, do it there than, and to bring people there to show video than to try to bring a truck like that over to a different continent. What it allowed COVID allowed was it allowed FBR to slow down, to go fast. Prior to March, when we were going to build it originally, we're only laying about 80 to 120 blocks per hour. But due to the pace that we had put upon us, we had to go out with it, knowing that there's some weaknesses in the strength or the speed that we could convey, the actuators, the saw, and so on. It gave us 3 months to bring the Hadrian into the shop and re-engineer all the weak links. So we went from 80 to 120 to 240 just by making a couple changes, and then making a few more changes. We're up to 280 to 300 blocks per hour. And with line of sight on, the next generation being closer to 1,000 blocks an hour. So hopefully COVID runs its course, and then we take the Hadrians that we have and get them outside of Australia and to different places to show off. We're committed to go to Dubai and the World Fair that I think is scheduled in October. So we will be there. And then hopefully in a construction site near you.
Awesome, Steve. Well, unfortunately, that's all the time that we have today. I wish that this conversation could actually continue a lot more. But thank you for watching Whiskey Talks this week with Steve Pierz from FBR. Steve, thank you so much, and we will catch up in the next Whiskey Talks.
Sure, and if anyone has any questions and wants to contact me directly, Andrew, feel free to give out my contact.
Absolutely. All right.
Thanks.
Everyone, we'll see you the next one. Bye for now.
Cheers.